but I don't feel like printing it out now. We're almost done.
So it's electronic.
Yeah. The problem is all the answers are online, so you'll have to flip back and forth. Okay, by the end of the lesson, you're going to be able to explain 2 congruent shortcuts. I'm going to preview the third one. Provide a counterexample to display why one congruent shortcut does not work. And prove that triangles are congruent using 2 of these shortcuts that we had. You haven't done anything with proofs, but when you want to argue with your parents about something, or you want to be a lawyer or argue about anything, you need to be able to reason deductively. And so that's what we're going to do. We're going to get started a little bit in how do you prove something's true. Because you'll say, and you'll say to your parents, well, how do you prove that? Prove that to me. I know you'll challenge them. Okay, we have a couple congruent triangles. So what we're going to do is write down what we know if the triangles are congruent. If they're congruent, then that means they're all the what? Eric, what does that mean? They're all the same size. Everything's the same. So on my triangles, and I almost messed up, read this, don't look at the pictures. But on my triangles, I know that angle A is congruent to what? Now we have to be particular about our symbols. Okay, TJ, you need to sit someplace else. Angle B is congruent to angle what? E. And angle C is congruent to angle F. I not only know that, but I know even more. I know that segment AB is congruent to DE. And we should put a little segment symbol above that. Okay, I also know that BC is congruent to EF. And I know that AC is congruent to DF. So I know all of that by definition. Okay, my board's off a little bit. So I could mark everything as congruent. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And then I could even mark the sides that are congruent. AB is congruent to DE. I'm going to check it there. I almost did it wrong. BC is congruent to EF. Whoops, I need 2 tick marks so I don't get confused. And AC is congruent to DF. Okay, this is a definition. So if I want to show that the triangles are congruent, if I want to really prove that to somebody, then I would have to show all of those things. I would have to be able to show them that the sides are all congruent, angles are all congruent. And you know what? Most of the time you don't have that much information. So it's not very good. So are there shortcuts? Are there theorems that if I know a little bit of this, I know that they're congruent? And the answer to that question is yes. Now we did similarity before. Now we're going to do congruence. And so there we have to get a few definitions, which would have been nice when we did similarity, because we've already talked about included angles. So this is kind of a review there. An included side is it's the side here that makes up the 2 angles, angle B and angle C. It's between those 2 angles. When you go around a triangle, you can't lift your pencil. You can't just jump from one side to another. You got to go around the triangle. And an included angle, this is my angle, makes up these 2 sides. So it's in between those 2 sides. Okay, so that's an included angle, and that's an included side. So we have to know what those are. Now, there are 6 different ways you can combine all the sides and all the angles. And they're all listed right here. Side, side, side. So if you know 3 sides of one triangle are congruent to 3 sides of the other triangle, then the triangles might be congruent. That's the question. So these are the possibilities. You could know 2 sides and an angle between them. You could know 2 sides and an angle not between them. You could know a side and 2 angles. So these are all the ones you could do. Sorry, I didn't clear the ink from this page. Angle, angle, angle. We already know that from similarity. Now I'm going to draw, not a very good one, but an equilateral triangle. And what are the measures of the angles of an equilateral triangle? There's 60. Good. If I draw another equilateral triangle, what are those measures? 60. Are those triangles congruent? Not necessarily. They might be, but they aren't in this situation, but they are similar. So this only gives us similarity. So we could already rule that one out. So if I know 3 angles, I don't know if they're congruent or not. So now let's go ahead and investigate some of these. If you know 3 sides of one triangle and 3 of the other, and they match, it doesn't matter if it's been rotated, flipped, upside down. 5 goes with this, 7 goes right here, and 8 goes over here. They're still congruent. So if I were to cut any one of those out, turn it, put it on top of here, they would all match up. Okay, you guys in the back? I don't think you're doing math. Aaron? Focus. Okay, this would be side, side, side. You got the 5, you got the 8, and you got the 7. So side, side, side. If you know 3 sides of a triangle, I know the triangles are congruent. I don't have to show the angles or anything. There's another one, side, angle, side. And this one I tried to draw, and I had started this like over here. But if I know 2 sides and an angle, I'm only going to get 1 triangle. And there was my attempt at drawing it, which really wasn't that bad. I could try and pull these apart and see if I can do them again. And I had to flip this one. I'll get rid of that a little bit. So I want angle B, and I've already flipped that over there. And I have side AB, and then I'm going to take this side here, and I have to go from B to C, so I'm going to put it there. And then I already know that this has to be AC. And that triangle doesn't look congruent to this one, does it? Dang it. So, because I didn't do it in the right order. I have to do side, angle, side. So I have to do the side, and then I have to do the angle, and then this side should work. Or is that not right? I might have changed the size as I was moving them, and there's AC. Yeah, they look more congruent now. And if I have side and an included angle on the other side, the triangles are congruent. It's not so easy to draw. Now, I didn't use the picture there. I did my own thing here. Side, side, angle spells a bad word if you spell it backwards. That's one thing. So it's not going to work. And remember, it didn't work on similarity.
Why can't we call it angle?
What word is it? Okay.
No, I mean, does it matter, like, what we call
It does matter. Order matters. So if this is side, side. So I have a side here, and an angle there. So I can't just go side, angle, side. I can't do that. You got to go around the way it works. And this triangle, given this situation, has 2 triangles. I could also do this. Oh, no, not that side. It's got to go someplace else. The angle has to say, and here's the other one. I'm not very good at drawing this. I can move this one. This side has to stay the same length, and I'll put it there. And this side's still the same length, the angle's still the same, but I got 2 triangles. I've got this one, and I got the big one. So, you can think of that as a hinge. So side, side, angle does not work. And if you can remember it spells a bad word, that'll help you remember it. Yeah.
So if you, like, bisect 2 congruent triangles, they should be the same.
Yep, they should. As long as you bisect in the same place on both of them. Okay, so we have side, side, side. We have side, angle, side. We do not have side, side, angle. We do not have side, angle, angle. We'll find that out tomorrow. Tomorrow we also will find out that angle, side, angle, but it's not in today's lesson, where that will also work. And I already talked about that does not work. So there's going to be 3. So for today, there's going to be side, 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 and side, angle, side. That's it. So let's do some problems. Can I say the triangles are congruent? And if I can, give me the reason.
Yes.
This is side, angle, side. And that's all you have to do. I like this homework.
Sweet as this. going to be problems. That's
Well, we'll be some, but we had problems with similarity. Okay, what about these two? I have angle, I can't do that. Let's start here. Side, side, angle. That's SSA. Are the triangles congruent? No. Because if I go backwards, which I almost did, then I spell a bad word. I figured that out. You can figure that out. What about this one? TJ, why would these be congruent or why not?
Side, side, side.
Side, side, side.
We do lesson 5 too.
I'll do that tomorrow. I have a quiz on the worksheet in the beginning of the hour.
But can we just do it today to get it over with? Because this one is so easy.
No, I've already kind of done it. Now, one other thing when you're looking at these, because it's not that easy if you have overlapping triangles. Here we have two triangles that share a common side. So if I take this triangle out, and I draw this other triangle, I automatically have a pair of sides that are equal. This AB segment is equal to that. It's called reflexive property. So if you have a segment that's shared by two triangles, I can use that in my congruence. Same thing with angles. Let me draw this one. And I'm going to pull it out. Then I'm going to draw this one. And pull it out. And guess what? This angle C is the same angle in both of those triangles. Now, I don't know about the sides, so I can't say they're congruent. But I know that the angle C is congruent to itself. Okay. Right now, can't you wait? I'm almost done. Okay, are these triangles congruent? These sides are congruent. These angles are congruent. I must have erased that. And this is congruent to itself. So what's the reason?
side angle.
Side, angle, side. Okay, TJ? You see that's side, angle, side?
Yeah.
Excuse the interruption. Is Grace Nichols there?
Yes, she is.
Did she come down? She'll be leaving.
Okay.
Thank you. Well, I could put that up there. Oh, there's still that. Okay. You guys, you can do side, 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 angle, side. And you really could do angle, side, angle, but that's tomorrow. So, are these triangles congruent? Garrett, are they congruent?
Yeah.
Why?
Both sides.
What? I need 3 sides if I'm doing sides.
Okay.
Danny, are these triangles congruent? Why? What kind of angles are these?
They're vertical.
Vertical.
So they're
There you go. If you're talking, please don't. It's side, angle, side. So sometimes you have to pull things out of the problem. Okay. Put your phone away, please. It's like kind of obvious. We're almost done. What about these guys? Okay, what about these? How about we pull these apart? Let's pull them apart. Okay, this is M, this is O, always congruent to itself. And I have this one as well. Whoops, not a very good picture, but it's close enough. This is OR, and here's O. Are those triangles congruent? You need 3 sides. I don't have that. Or you need side, angle, side. Or angle, side, angle. We don't even have that either. I don't have enough information. So no. Not enough. Oh, I fit. Info.
Could we write that answer?
Yeah. Yeah, I need something else, TJ. I need another side or another angle. And I need the other side in the right place besides. Okay, Miles? How about those triangles? These angles are congruent,
Oh, wait. Never mind. Side angle.
but this is side, side, angle. And side, side angle does not work.
Oh, wait.
And that's what you say. Got any question?
Wait, so
And
the
then-
order does matter. So side.
Order matters. That's the good question. Did you guys get that? You can't just jump around the triangle. You got to go in the order of the triangle.
How do we read it then? That's why I'm using.
Side, and then go down to the side, and then onto the angle.
But if the angle is over there.
If I had the angles at B, for instance, and D, then I would go side, angle, side.
So you read it kind of like from the left. And
I could go the other direction too,
you
but
just have to read it.
I can read this side, angle, side. It's okay. You just have to not lift your pencil as you go around the triangle. Okay, if you have a packet, you have a hard copy of the homework. Let's look at number 1. Okay, you guys? Shh. Aaron, Jake, are those triangles congruent, and if they are, why? Okay, you can't answer this question, you didn't listen. Are these triangles congruent? Yes, because you have side, angle, side. And that's all you got to do. All you have are 2. Tomorrow you get ASA, but okay, so there it is. Make sure that these things match. Make sure that they match. Okay, now we're going to go over homework. All I got is one left. I just got one. Yeah, it's in the note packet.
What? Is the homework?
It's right here. It's in the note packet. I did it by accident. Okay, get your worksheet out. Johnny, you got work to do on that worksheet, I hate to tell you. Sorry. And you need to ask me questions.
Go to the bathroom.
Yeah, where's your worksheet? Yeah, you haven't done it. Yes. Okay, we're going to do questions on your worksheet.
I finished this before break. I can't even remember like anything about it.
Well, we should probably do it again.
I have another copy.
Yes, no, I don't know if I have any, no, I don't have any left. They're all electronic. Electronic.
I just have no idea.
Well, it's electronic, so it is on your iPad. Okay. It's called PSC 2.1 through 2.3 review worksheet. It should be in the homework packet. I know it's in the homework packet. That's it. Yeah, it is. Look at the homework. No. Yeah, there it is. Right there.
Oh, that's the full package.
That's the full thing, which you should have been doing. Are there questions on these? I expect there to be questions. Yes. Number 1. Number 1 is the angle bisector theorem. Okay, notice I don't have 2 triangles, I have 1 triangle. So there aren't similar triangles here, but the angle bisector theorem says that if I ratio 5 to 8, that's the same as this segment to this other segment, x to 10 minus x. You cross multiply, so it's 50 minus 5x. Whoops, don't forget to distribute that 5. Add 5x to both sides, so 13x equals 50, and I would never guess that for an answer, 50 thirteenths.
How do you find y?
There is no y in that one, that's a typo.
Oh.
To do number 2, I did this 2 ways. I found the area of the little triangle, and it said, well, the area from one, because they're similar, relative to the area of the other one is the ratio of the sides squared. So I found the little triangle and multiplied by the ratio of the square of the sides. That worked. Otherwise, you could just say x is to 4 as 16 is to 8. So x is equal to 8. And then find the area that way. It doesn't really matter. What about number 3? Because 3 and 1 are very similar. Aaron, did you get number 3?
Nope.
Okay, so let's first find x. Why is x 24 your right?
Okay, behind me on the board, I've written these down. You gotta know them. There's not that many to know.
Keep it up on the test.
No, you need to know them.
11.
You need to know them. So x is 24. Now, could you use Pythagorean theorem? Sure. It'll take more time. If you remember, you square the 3 and you basically divide it in half, which is 4 and 5. Square the 5 gives me 25. Well, half of 25 is 12 and 13. It doesn't go evenly. 7 squared is 49. Half of 49 is 24, 25. If you remember that little trick, then you've got them. Because I couldn't remember 11. 11 squared is 121. Half of 121 is 60 and 61. Okay, so now to get y, I have to go 7 is to 25 as, how am I going to do that? Y is to what? If this whole thing's 24 and this little part's y, how big is this part that's left?
Y.
24 minus y.
Yeah.
So I get 25y. 7 times 24 I've done today, so I know it's 168. Minus 7y. Add 7y to both sides, I get 32y equals 168. And if I divide by 32, I think, do I get 5.5? I think I do. Okay. Let's look at that triangle. This is the problem. People couldn't get z, but z is not hard.
Actually at 5.2.
Or is it 5.2? No, I got it exact.
68 divided by 32.
I got it exact.
Yeah.
168 divided by 32. Oh, you're right.
I didn't know.
I'm not remembering it right. 5.25. I thought it was something else, but anyway.
Is it important to get your numbers exact?
Yes.
Okay.
Okay, how do you get z, you guys? Right there. Okay, girls, how do you get z? Whose theorem?
Where is it?
Right there.
It's the angle bisect.
Oh,
No, it's Pythagorean theorem.
the third.
No, it's Pythagorean theorem. 7 squared plus 5.25 squared
Oh, I see.
equals z squared.
Pythagorean.
Just Pythagorean. So
So it's just a multiple step problem.
they all are multiple step problems. No, that's why you need to do the homework. And there are homework quizzes out there on the homework. I'm giving you a quiz on this tomorrow. Are we okay with the front side?
Yeah.
I am. Yep. Let's see.
Oh, and also can we do 8?
4, these are similar. These are similar triangles. So 3 is to 6 as 4.5. It's not an angle bisector, it's a median. It bisects the side. 4.5 is to x. As long as they both bisected the side, then they're both the same corresponding part. Which one now? Next one? I'm assuming you know how to do that.
Number 8.
And I would reduce that 1/2 equals 4.5 times x over x. So x is 9. Which one, number 6? It says the sides are similar, so I have to find the sides that correspond. I might not have done that right. Okay, let's see. Which is the biggest one? 6 is the biggest one. Is to 2 1/3. Then let's do the smallest one.
3
And 3 is to 1, right? And you could cross multiply. That's 6, because if they are equal, then they're similar. And a 2 1/3 is 8/3, right? No, it's not 7/3. 6 plus 1 is 7/3.
Can you just do it on the calculator, like divide 6 by 2.333?
Sure. 6 doesn't equal 7, so the answer is no. All the sides have to be proportional if they're similar.
Can we do number 8?
8. Again, the corresponding parts must be proportional. So x is to y as diameter is to diameter as height is to height.
Oh, so they would be similar.
They're similar.
Oh, so it's just like that.
Put numbers in if you want.
Okay. All right, that helps. That probably.
If these weren't equal, then you'd say they're not similar. Okay, how about this one? I know we had a question on number 17.
Oh yeah, I can figure it out.
Okay, girls? Questions on this page? About 14. Jake, how do I do 14?
I'm not sure.
Yeah, we will. If the ratio of the heights is 2 to 5, what is the ratio of the volumes? It's 2 to 5, not squared, cubed.
So it would be 8 to 125.
Right. These are easy problems. If you can't do those, you need to come in and see me, get some help. Okay, 17 is a prism, rectangular prism. Come on. Okay, the first one holds 64 gallons, which is a volume. And then I'm going to draw a smaller one. This is a multi-step problem. And it holds 8. Okay, TJ, how am I going to do this? And it says I have a cover for the smaller tank that has an area of 1.5 square centimeters.
Yeah.
What is the area of the larger tank? That one. Well, I can do this. The area of one to the area of the other is equal to S1 over S2 squared. What do I need to know? I know one of the areas. If I know one of these, I need to also know the ratio of the corresponding sides. Right? Okay. I can find that if I'm clever. And I have a volume here. Volume of one to volume of the other is equal to the ratio of the corresponding sides, what? Not squared, cubed. So if I put in the volumes, which I have, the first volume is 64, the second volume is 8, equals S1 to S2 cubed. So I'm going to divide that because that's easier. What's 64 divided by 8? So it's 8 over 1 equals S1 to S2 cubed.
So it's just 2.
How do you undo cubing? You cube what? That's right. Looks like that, if you haven't seen it. So this is 2 over 1 is the ratio of my sides. It's a two-step problem. Now, to do the area, there it is. It's side 1 to side 2. Okay, I want to find this area, that's A1. The other area is 1.5 equals, and that was 2 to 1 squared. And I'm sure you're going to find mistakes in my answer keys. I didn't check them. So A over 1.5 equals 4. So A equals 4 times 1.5, or 6 square feet. It's a two-step problem. You have to think about it. So when I thought about it, I said, well, I have the volumes, so I don't know what to do with them. And I want to find the areas. I know one of the areas. I knew this area. If I only knew the ratio of the sides, then I could do it. So then I went back and said, well, the volume will give me the ratio of the sides. I don't know what the sides are. I just know I have the volume of them. That's all. Yep, it's 6. So we are reviewing, TJ. This is reviewing everything I talked about yesterday. How about this page? to do number 18, this is the side splitter theorem. Now listen carefully. These sides have been split, but the bases have not been split. So all I get out of this is that 6 over 9 is equal to 8 over x. That's all I can get. If I want the bases, I gotta do something else. That's how you do, well, that's how you do the top ones. How about number 19? Are these lines parallel? This only is true if this line here is parallel. Well, it's 2 to 3, the same as 3 to 4.5. And the easy way to know that is to cross multiply. 3 times 3 is 9. 2 times 4.5 is 9. Yeah. That's the easy way to do it, cross multiply. You could take your calculator and divide it out. But what about 21? 21's different. I would like to say, let's call that x. I would like to say 12.5 is to x as 8 is to 12, but that would be wrong. These sides were never split. So I have to use similar triangles. This triangle here is similar to the big one. So that's 8, and let me trace out the big one. So now I find the corresponding sides. What corresponds to 8 on the big one? Not 12, 20. 8 plus 12. That's why there's a 20 there. It's great if you don't, if you're only looking for the sides. But I can find PR. That's easy. 3 is to x as 5 is to 10. And then I reduce because that's 1/2. So x equals 6.
So can you remind me of the side splitter here?
The side splitter, this line's parallel to the base, divides these sides proportionally. The ratio of this side to this is equal to the ratio of this to this.
Oh.
It doesn't show up on my video. Now, what's RI? This is 9, this is 15, this is a right triangle. How big is RI? Actually, PQ is easier. This is a right triangle. How big is PQ? TJ, how big is PQ? PQ.
PQ is 4.
4. It's on board behind me. This is a multiple. They're similar. It's better be a multiple of it. This is 3 times 3, 5 times 3. This is 4 times 3, or 12. It's the third multiple of the 3, 4, 5. How about 25? Did you guys get 25, Phoebe? You have to think of it as 2 triangles. 2 separate problems. Let's look at this one. And let's see. Let's do this. Can I pull that baby out? That wasn't the plan. Come on, take the green one. I hate it when I grab the wrong thing. There we go. Okay. So this is 9, this is 15, this is 12, and this is x. That's the side splitter theorem again. It's just sitting on its side, not right side up. So 12 is to x, as 9 is to 15, which reduces to x. 3/5, right? And you multiply. So 3x equals 60, x equals 20. And then you're going to say, well, how do I find y? Because I don't have right triangles. It's the same process. I'm going to take the big triangle. See if I can pull it out. Keep grabbing the wrong thing. Oh, look it. I got that. Okay. So this is 12. This is y. And x was 20, right? And this is 12. There you go. 12 is to y. I could do y is to 12. It doesn't matter. as 20 is to 12. Cross multiply, you're done. Same thing works here. 3 is to 4 as P is to 4. And then you can do this. 4 is to Q as 2 is to 3 is to 2. It would have made the last unit a lot easier, 2 units ago a lot easier, if we had had the side splitter theorem. Problem is, though, you apply it when it doesn't apply. That's the problem. Other questions on this? I did a lot of this worksheet. You're going to have a quiz on it tomorrow. You need all my proportions. That's not done. What?
Are we gonna have a problem like 25?
I don't know. I haven't looked at it that closely. That's pretty hard. I mean, those are pretty hard.
I forgot I had phones there.
Okay, I'm here to ask questions of. Now, don't forget, you still have those homework quizzes to do. Now, if you are, you guys, if you are missing any homework quizzes, I went and did all my homework quizzes. I put them into my grade book last night. They're all listed in Skyward. If you look at Skyward and say, hey, wait a minute, I did that one, then you're going to either send me an email or write me a note, and I might have missed it. It's possible.